Hi everyone, my name is Julie and I'm a member of the FreeFlyer Technical Support team at AI Solutions. Today we're going to be talking about FreeFlyer's Runtime API. We'll talk a little bit about what the API consists of in general, and then we'll take a look at a hands-on example application written in Python. So the FreeFlyer Runtime API provides a programmatic mechanism for interfacing with the FreeFlyer engine directly from a host application. So what this lets you do is interact with mission plans and objects that were created inside the mission plans from your external application. Note that the API does not allow for creation of FreeFlyer objects, so you would want to create any FreeFlyer specific objects like a spacecraft in your mission plan. Without the API, your ground system architecture might look something like this. You'll have your own application and it calls FreeFlyer's executable, and FreeFlyer outputs some sort of file or database or other type of message that is then returned to the application. These can go both ways. FreeFlyer does have native interfaces for interacting with external resources, but the API can simplify this process. With the API, you can access FreeFlyer directly from your application. So you can build your own application with FreeFlyer as a computational engine or a visualization tool or whatever you need with direct calls that allow you to pass data back and forth with no in-between functionality. The Runtime API comes installed with FreeFlyer 7.0 or a more recent version. It's available on both Windows and Linux. We support currently 5 different interfaces, so there's a C/C++ interface, a C#, Java, Python, and Matlab. And we generally recommend that you use one of the native IDEs for any of these languages for creating and editing your applications, like Visual Studio for C or C#, NetBeans or Eclipse for Java, or Spider for Python. We'll be looking today at an example application written in Python, and we'll be using the Spider IDE to do that. When you're building an application, there are 6 basic components. First, you include the API reference, you create the engine, load a mission plan, prepare the mission plan, execute the script, and then clean up the script. And we'll talk about what each of these means. So the first step is to include the API reference. In Python, this can be done by importing the entire interface or specific components, and each of those are shown here. The first line imports all components of the Runtime API interface, and the other lines that start with from show how to import specific pieces. The Runtime API reference is found in your Documents folder under your FreeFlyer directory in Runtime API, and it's also available through the Python wheel if you want to access it remotely. Second step is to create an API engine. This is a simple constructor syntax, so the main argument that you're going to pass in would just be your FreeFlyer install directory. And you can use operating system specific commands to access your FreeFlyer directory if you have it stored as an environment variable, which it is by default. In Python, you can create an engine with a with statement to ensure that it's properly disposed of, even if an exception occurs. This is good practice, and we'll see how this is done in the example that we look at today. There are a few other optional arguments that you can specify in the constructor when you're creating your Runtime API engine. So the console output processing method lets you redirect MissionPlan console window output either directly to the host application or to the Runtime API to be retrieved by the getConsoleOutput method. And you can also select a windowed output mode, which gives you options for displaying the FreeFlyer output workspace. So you can choose to generate output windows, which would generate a full output workspace that you can manipulate just like you would in FreeFlyer proper. You can also choose to hide the main output workspace but show any unconstrained windows. And finally, you could choose to generate images only, which would hide all output windows but let you use methods like save image in FreeFlyer script. Once Once your API engine is created, the next step is to load a mission plan, and you can do this in a few different ways. The most common probably is to load your mission plan from a file. So if you've written a mission plan and you've saved it in a .missionplan file, you can just call the load mission plan from file method. You can also load a mission plan from a string. This would be an XML format to match the structure of a mission plan file. You can load a FreeFlyer script from file. So this would let you access FreeFlyer script without being formatted as an actual mission plan. So this would just be if you copy pasted some FreeFlyer script into a text file and loaded it that way. And similarly, you can load FreeFlyer script from a string. And that would be a very simple way to access FreeFlyer script directly. Again, not in a mission plan XML format, just FreeFlyer script. Once the mission plan is loaded, it must be prepared before it can be run, and the way to do this is by calling engine.prepareMissionPlan. And this executes a few necessary startup routines. It initializes any objects that have been created in the object browser in FreeFlyer. It sets the mission plan to line 1 of the script for execution, performs the script validation, and runs a syntax check to make sure that everything will run properly. And then you're ready to run your mission plan. Once it's been prepared, you can execute the script in a few different ways. First, you could just call the execute statement method. This will execute just one line of code from the current location in the mission plan. You could execute all remaining statements from the current location. That would just run through the entire script. Or you can use API labels to execute until certain points in your mission plan, and then, for example, pass information back and forth. So API labels, we'll talk about those a little bit more, are inserted into FreeFlyer script and allow you to access different points of your mission plan from your external application. So your application can run to any API label that's after the current location in the mission plan. You can put these inside of loops if you need to access the same point multiple times. These are just set up as strings, case-sensitive strings, and you can use regular expressions. And the way to run to these specific points will be to call the execute until API label method. When we look at our example, we'll talk about how we can actually pass information back and forth at these API label points. With the API, expressions can still be retrieved and handled even after the mission plan has finished executing all statements. So once you are truly done with your mission plan, you'll need to call the cleanup mission plan method to release all the resources that are being used by the current mission plan and put your API engine back into the unloaded state so it can either run another mission plan or simply release all resources so that you don't end up with any memory problems. This is very beneficial for performance if you want to reuse the same engine, because then your engine doesn't need to be initialized again. You can just call the cleanup mission plan method and then start from the load mission plan step in this process. Your FreeFlyer installation comes with a number of sample applications in all supported languages for the Runtime API. And today we're going to go ahead and take a look at one of these examples written in Python. So here I have opened the Spider IDE, and I'm going to go ahead and go through the whole process of opening up the example application. So this is exactly how it should work on your computer if you have FreeFlyer installed. I'm going to go ahead and just hit open, and then I'm going to navigate to my Documents folder, FreeFlyer, my current FreeFlyer version, Runtime API, Python, Examples, Source, and we're going to take a look today at the running a mission plan example. Now you'll notice there's an examples.py file here. You can also run that just to run all of the included examples directly, but I want to take a deep dive into a single example, so we're going to take a look at running a mission plan. And I'll just open up that script. And as you can see, it launches in the Spider IDE here. And this IDE includes a console window on the right, and that's where we'll see our output being generated. So I want to scroll down and try to go ahead and identify those 6 components of a basic application that we talked about. So the first one is to include the API reference. We can see that being done here with the import statements at the top. So we have from AI solutions.freeflyer.runtime API engine, import, and then the component that we wish to import. We have this set up to import a few specific different components of the API reference, but you could also just use the import statement and call import AI solutions.freeflyer.runtime API if you want to include all included pieces of the API reference. I'll scroll down a bit. We have a class called running a mission plan, and then inside of the create and run engine method definition is where we see our runtime API engine being created. So the second step in our 6 components was to create the API engine. Here we are passing in our FreeFlyer install directory. We specify the console output processing method as redirect to runtime API. So that means that if FreeFlyer produces output in a console window, we could use the get console output method from the API to retrieve that output. We actually won't be doing it in this example, but it's just a way to show how that syntax would look. And we've set the windowed output mode to none for now. We're going to change that later. You'll notice that the ff install dir argument is being set a couple of lines above through the example utilities class. And this is just another Python file that is used for all of these built-in examples. And you can take a look at that as well. This uses environment variables to retrieve the FreeFlyer installation directory. The third piece of our 6 components is to load a mission plan. So we can see that being done with the line engine.load mission plan from file, and we pass in the mission plan path. Again, we're using the example utilities to set the mission plan path earlier, and that's just retrieving the examples path for all of the example mission plans that come with the API examples, and the one that we're going to be looking at today is called propagate state. After we've loaded the mission plan, we need to prepare the script, so we simply call engine.prepare mission plan. And then our 5th step is to execute the script. So we can see this being done in the bulk of this with statement, which again is being used to dispose of the engine resources. We're going to call execute until API label, and the first API label that we'll reach is called set state. Then we're going to pass in our initial state for our spacecraft using the set expression methods. So we can see here that we're setting a time span and 2 arrays, and those are going to be in FreeFlyer syntax. We'll talk a little bit more about that in a minute. After we've set our state, we execute until another API label called getState, and that is the end of our mission plan, so we are done. After we've retrieved the state from FreeFlyer, we'll call cleanup mission plan to clean up the script, and that is the 6th step of our basic anatomy of an application. So I want to open up FreeFlyer and take a look at the propagate state mission plan. So I'm just going to open. Again, we're in our FreeFlyer version directory. The mission plans that go with the API examples are located under Runtime API, Examples Common, and we're going to choose Propagate State. So these same mission plans are being used for all languages in the API examples. This is a very simple mission plan written entirely in FreeFlyer script. We create a spacecraft object called S. We set the epoch of that spacecraft. We have an API label called setState, which is going to be used by the API to set our initial state. We'll propagate the spacecraft for 1 day in a while loop, and then we'll run to getState to pass through that while loop and retrieve our spacecraft state. I'm going to go ahead and add a line here because we want to compare the output of what we get if we run this mission plan standalone versus through the Runtime API. So I'm just going to report s.epoch.2days and s.getCartesianState. Save my mission plan. If I run this in FreeFlyer, we'll see that our epoch is 25,198, and we have our XYZ and velocity X, Y, and Z reported in a report window. So that's what our mission plan looks like. I'm going to go back to the Runtime API and we'll take a look at how these two pieces are analogous. So, like we said, we're going to run until the set state label in our Python application, and then we're going to pass in an initial epoch and an initial position and velocity for the spacecraft. And then we will run to the getState API label, which, as we just saw, will propagate the spacecraft for 1 day. And then we'll retrieve that state and report it out to our console window on the right. So I'm going to go ahead and run this by hitting this green button. We load the Python modules, and we have our print statements shown in our console window here. So we're walking through each step of the process, and we see that the final state does not match what we saw in the mission plan, and that's because we changed the initial state of the spacecraft. So we know that we are accessing our spacecraft state properly from the API and then propagating it and getting a different result than what we would get if we just ran the mission plan standalone. So it's great to see that this application is working the way that we'd expect. We're interfacing with FreeFlyer just the way that we planned. But the mission plan is honestly a little bit boring, so I want to jazz it up a little bit and add some output. So I'm going to go back over to FreeFlyer, and inside of my while loop, I'm going to add a view command. So this will just generate a simple 3D view of our spacecraft while it propagates, and we can run the mission plan again to see how the output changes. Now we have a 3D view as well as our report statement. So if I wanted to show that from the Runtime API, I'm going to have to change my windowed output mode. So I'm going to go back to Spider, back to my application. And the first thing we need to do is remember that we didn't import every component of our API reference, so we want to add an import statement for the windowed output mode component. So I'm just going to add that at the very end of my import statements. I'll say from AI solutions.freeflyer, and we can see that Spider is giving us some help with autocomplete, .runtime API, .windowed output mode, and we will just say import windowed output mode. So this looks just like all of our other import statements, including console output processing method, which is the other constructor argument. And then we can scroll down to our engine definition. And instead of saying windowed output mode equals none, we'll change this to windowed output mode dot. And we can see that once again, because we imported the reference, all of these autocomplete options are available. And I'm going to select Generate Output Windows. Make sure to save my work. And now, if we run our application, we should see the view window that we created in our mission plan. So once again, I hit run. We're seeing our console output on the right. And then we launch FreeFlyer and we see the view window that we created. It closes automatically. We're going to add a console input wait so that that doesn't happen and we can actually see it for a little bit longer. So I'm just going to scroll down here, and before we clean up the mission plan, I'm going to add an input, and that will just cause Python to wait to continue execution until it receives any keyed input from the user. So one more time, go ahead and run. We see the same output in our console window, and we get our 3D view from FreeFlyer. And this time it doesn't close right away. You can close it directly from here. This window you can interact with just like you would any FreeFlyer window. I can open the properties editor to change properties of the viewpoint. This is all standard to FreeFlyer. It gives you full access to the capabilities of the output workspace directly from the API. So I'm just going to close this, and we can see our application is waiting, and I'll just hit enter to clean up the mission plan and finish execution. So I hope you enjoyed this deep dive into the running a mission plan example. Remember that all of these examples come included with your FreeFlyer installation, so I definitely encourage you to take a look at the other examples. Here we can see we have a variety. These are all the Python ones, but if you go back up to the top level API directory, you can see examples for all different languages. These are an excellent starting point for building your own applications and include different features of the Runtime API. I also want to call attention to the references document. If I open this up, we have a bindings reference for each of the supported languages. Matlab is used through the C# or Java bindings. And so if I clicked on Python, we can see the different classes that are included. Click on Runtime API to get detailed descriptions of each of the available methods. This looks very similar for any of the languages with a slightly different structure. So this is where you would find detailed documentation for all of the different components of the API for that language. You can also find a lot more information in the FreeFlyer help file. So if I jump back to FreeFlyer and open up the help file, the application program interface section of our help file includes descriptions of the Runtime API, different examples for things like error handling different types of expressions, discussions of asynchronous programming, and some more advanced concepts. And it also includes descriptions of all of the different sample applications that are included.
If you have any questions, you can reach out to our technical support team by email at techsupport@ai-solutions.com or by phone at 301-306-1756 extension 2.